Mackenzie's going to tell us a little bit about some workflows using Lidar and terrain, common use of Global Mapper. Well, over to you, Mackenzie.
All right, thank you, David. As David mentioned, Mackenzie Mills, and I work here at Blue Marble as an application specialist, and that means that I do work in the Global Mapper program every day. I have here some LiDAR point cloud with some imagery behind it, and today in this tips and tricks segment, I'm going to take this point cloud and take it all the way through to a terrain layer and then to some contour lines. So first, just a little bit about this area. This is a coastal area with some sand dunes in Brazil. I can zoom in on this image a little bit, and this big portion in the middle, that's all sandy area. And we have our point cloud laid over it. This point cloud already has some classification done, so we're not going to deal with classifying that point cloud. I've just changed the LiDAR draw mode to color by classification, and we can see that the brown areas are points classified as ground and the green is classified as vegetation. So we'll jump in and start to generate some terrain grids. We'll use this create elevation grid tool up here, and the first grid that we are going to create is going to be using the triangulation method. So there are some other options in this dialog. We're going to go with the defaults for now, but you can specify your grid spacing if you are generating a terrain grid and you need a specific pixel size or pixel resolution. But we're just going to go with the defaults and we'll create this triangulated grid. So what this is doing, this is taking all of the points in the point cloud and creating a network of triangles using those points as vertices. And then that's a vector network. And then Global Mapper goes through and interpolates the faces of those triangles to generate that terrain grid. And since this is using all of the points in the point cloud, this takes a little bit longer than some of the other methods because it is just so detailed. So we'll see this come up in just a second. This point cloud isn't too large, it's only about 7 million points, but it still does take a little bit longer to include all of those points when generating a terrain grid. So as that process finishes, we can just look at this terrain grid here, and you can see that it does appear a little bit rough. We didn't filter out the vegetation, so that is included, gives it a little more texture. But the next method we're going to use to create a terrain grid is going to be a binning method. And to do this, we'll change the method to binning minimum value. And we're using the minimum value method because we're trying to generate a grid that maps the ground. And the minimum elevation value as this process runs is most likely to be ground, as LiDAR data is not ground penetrating. Again, we'll just go with the defaults. And as you can see, that grid generated a lot quicker than the tin grid. And the binning method spatially bins the point cloud and then takes the minimum value from each of those spatial bins to generate this grid. So for a quick comparison between the two methods, we can use the image swipe tool. And I'll swipe back the bin grid layer, and you can just visually see that the bin method creates a smoother elevation grid, just as I swipe that back. To look a little closer at that, we can use the path profile tool and just draw a small path profile, zoom in a little bit, and we can see that this red line filled with green is our bin grid. That looks pretty smooth. And this blue line that you see that's a little bumpier, a little choppier is the tin generated grid. So it's bumpier and choppier because it takes every LiDAR point into account when generating the grid versus spatially binning and reducing the number of points it's actually taking into account to create the grid. So this can have a few impacts in your analysis. Since we are trying to model the ground, the bin grid that looks smoother is using the minimum values is more likely to accurately map the ground. And since we will be generating some contour lines, the bumps in the tin grid will make our contour lines more jagged looking and just not as pleasant if you're trying to use them in a final map. So what we'll do here is we'll continue with the bin method grid that we generated. So I'll disable the tin layer there. And now we'll generate some contour lines. For this, we'll use the Generate Contours tool. And generating contour lines in Global Mapper is pretty easy. We have this tool, and there's a lot of options in this dialog. We're going to set our contour interval to 5 meters. And you have some options. You can set it to whatever interval you would like, or you could generate a contour line only at one specified height. This can be very useful if you're looking to just view something below or above a certain height. For this example, since it's a coastal area, you might want to mark a high tide or a record tide line and then use that in your further analysis of the area. But for this example, we're going to just create 5-meter contours over the whole elevation grid. Down here, we have a Find Local Peaks and Depressions option. We are going to do that, and this will find the local high spots and low spots in our data set based on the generation of those contour lines. We'll click OK, and those contours will generate. And so now we've got some brown contour lines on top of our grid here. These yellow triangles are local peaks, and we've got a couple blue upside down triangles that are local depressions. So this is starting to have a little more meaning than just that image and that point cloud. So what we can do now is we can add our image back in. We can put our contours right over the image that we have of the area. And this is good just to give you some visual context of the features in the area. You know, maybe you're referencing something based off of a road, or just give a little visual context of the coastline here. And so you can start to get to know your area a little bit better. But still looking at this image, you see that this big area of sand looks fairly flat in this image because it's just a 2D image. Now, on our elevation grid, you can see it's hill shaded, it clearly has some relief. To apply some of that texture from the hill shaded elevation layer to our image, we can actually texture the image and apply that hill shading. To do that, I'm going to drag our image so that it appears on top of our elevation grid layer. The layer is still on displayed just underneath that image. And then we'll open the image options. You can right click on the layer and choose options. And on the display tab, you just check this box to texture the map, click apply. And you can see that this sandy area that looked pretty flat now is showing some relief. It's shaded, like it actually has some texture. We could throw our contours back on there, and this then begins to look more like a meaningful map. So going further than that, we can look at this in the 3D view. And with the image layer displayed, I'll turn off our contours there. With the image layer displayed over the terrain grid, you can see that that image is actually draped over the terrain grid, showing that in 3D. So if you're looking to create a 3D graphic or do some analysis in 3D looking at that area, you can color that elevation grid with your image. You can also color your Lidar points from the image. To do this, I'm going to go to the layer options for the image and turn off that texture. So it just displays as the 2D image. And we'll pull our point cloud back in here. I have it displayed as by classification now, but we can change that to RGB elevation. And this is showing the elevation values for the point cloud because there are no RGB values. We can apply those values from our image using this Apply Color to Lidar Points tool. In this dialog, we're applying color to our point cloud here from our image layer. We're applying the RGB color. We click OK. It'll pull those colors from the image and add them to the points. And now you can see that the point cloud, I'll turn off the image here, so we're just showing the point cloud. has those RGB colors from the image. And that just gives you a little more context when viewing this point cloud. You can always change that draw mode back to elevation if you do want to just look at those elevation values. So as you can see, there's a lot you can do in Global Mapper, just taking a point cloud to do some basic terrain analysis and view the data in multiple ways. David, have there been any questions that have come in?
Unmuted.
Yes, actually, a couple here. Talking about the binning method, somebody's asking about the binning. Which is better, the binning or tinning method? And I think that's obviously very objective. You did address that, and maybe reiterating that point, when you're binning and when you're tinning, which is best, I guess, is the question.
Well, that really does depend on what your end goal is. Comparing the binning and tin method, the tin method does take every point in that point cloud into account. So if you've gone through and you've thinned your point cloud, or in our grid creation options, you have the option to filter the LiDAR points. We didn't do this, but you can filter them to only use some ground points. So if you have cut down your points in your point cloud to only the ones that you are sure you want to use in your grid generation, then the tin may provide a great result. It's also good if you're looking to save a vector triangulation network, because you can do that from this grid creation options when you're using the triangulation method. Yeah. And then the binning method, we have a bunch of different binning methods. The minimum value that we use to get that lowest elevation value, you can also use a maximum value if you're looking to try and grid those vegetation or building features that may appear in your point cloud.
Yeah, and we've had, those of you who have maybe participated in some of our training classes, we've had some discussions as well as to which is correct. And there's an argument could be made for saying that the tinning method is correct because it does factor every point, whereas the binning method obviously aggregates it just a little bit. Another question here in relation to binning, comment about how it looks awesome. Can you kick out, I assume kick out means export, can you kick out a 3D mesh from that? Is that possible with your binned elevation grid?
Yeah, so we do have a tool to generate a 3D mesh. We can, believe it is in the layer. I don't know what menu this is in, if you have an idea, to generate a mesh from your elevation grid and your raster image.
I think it's part it's included in the LiDAR module, so it's a LiDAR module toolbar button. You'll see it right there in your toolbar. So yeah.
Oh, well, I did find it in the layer menu as well, but it's this create mesh features from raster and terrain. And so I've got my binning and my binning grid and my imagery there. And you would create that using these layers. We'd click OK. This does take a little bit to construct that mesh, so I won't execute that here, but it will create a mesh layer that you could then export to an OBJ or another mesh, another supported mesh format.
Perfect. And to clarify, the option in the LiDAR toolbar or LiDAR module toolbar is obviously directly from the point cloud. So going from your binned model using that method from the analysis menu works. Excellent. Thank you, Mackenzie. We will be hearing from you again in the afternoon.